Today we are going to learn about the law of adiabatic process. The law of adiabatic process is P times V raised to gamma is equal to C. So to derive this one, let us consider firstly the first law of thermodynamics. Delta Q is equal to delta U plus del W. But for adiabatic process, we know that delta Q equals to 0. So heat interaction is 0, that's why delta Q is 0. So here for adiabatic process, heat interaction is 0 or there is no heat interaction, so dq equals to 0. Now our equation 1 will be, or let us say that the first law of thermodynamics for adiabatic process will be as follows, that is du plus dw equals to 0. We know that du is equal to mcv delta t by delta t1 or delta t. We can just say that mcv delta t. If mass is 1 kg, then what happens to du? Du will be equals to cv dt. Yes, so here du will be equals to cv dt and work done will be p dv. The change in volume will give you the work. So the equation number 1, that is dq is equal to du plus dw, will be as follows, that is and that will be dq is equal to du plus dw. Yes, we know that for adiabatics du is 0 and dq is 0 and du is cv delta t plus p delta v. Now let us consider a characteristic gas law. Okay, now let us consider characteristic gas law, which is, or we can say from gas law we know that PV equals to mRT. P is pressure, V is volume, m is the mass of the gas, R is gas constant, and T is the temperature. If m equals to 1 kg of mass of gas, then PV equals to RT. Now let us differentiate this gas characteristics gas law. What we will get is as follows, that is P delta V plus V delta P. We are using UV rule here, UV rule of differentiation. That will be equals to R is a constant, that is gas constant, and T is variable, so it is dt because it is varying. dt will be ultimately equals to P dV plus V dP divided by R. Now we are going to substitute the value of dt that we found out just now to equation Cv dt plus P dV is equal to 0. Here we are going to substitute the value of dt. So if we substitute the value of dt in above equation, that is Cv dt plus p dv is equal to 0, what we are going to get is Cv by R times p dv plus v dp plus p dv is equal to 0. As we multiply, we will get this one, and p, when we are finding common in denominator, we are going to get pr dv equals to 0. Okay, now we know that r is equal to or we can say, now let us consider this thing, that is now dividing throughout by P, that is pressure, V, that is volume, and Cv, specific heat of dV by V plus dP by P plus R V Cv dV equals to 0. Now what we are going to do is, we know that R equals to Cv minus Cp minus Cv, so dV by V plus dP by P plus Cp divided by V Cv minus dV minus Cv V Cv dV, Cv Cv cancel. Now what we are going to get is dV by V plus dP by P, that Cp by Cv is equals to R. Now we get is dV by V plus dP by P plus R dV by V minus dV by V equals to 0. We know that here dV by V and there is minus dV by B, so that will cancel out. What we are going to get is R dV by V plus dP by P equals to 0. Now we have to integrate to get in terms of log, that is gamma log V plus log P equals to 0. Gamma in the front, that will be log V raised to gamma plus log P equals to 0. According to the law of log, we know that if there is plus in between, we can multiply it. That will be PV. I forget to mention the constant k minus k. Let us consider that minus k is the integral constant. Now what we are going to get is, let's take that constant to another side, and in the left hand side we have PV raised to gamma is equal to k, that is constant. That is known as the law of adiabatic process. Thank you for watching this video. Please subscribe and like this video.